In this session, we're going to look at exploring and analyzing some data using both the graphs and displays that we learned about last week and the new material from Chapter 3 from this week. The data set that we're going to look at is in our StatCrunch class group. It's called Low Birth Weight. So feel free to pull it up and follow along as we go. Here's the description of the data set. And this is about low birth weight babies and some of the factors that might contribute to a baby being low birth weight. So what we're going to look at is one particular relationship that we could investigate. The one that we're going to investigate today is whether there's a difference in birth weights for babies whose mothers smoked versus babies whose mothers didn't smoke. And in our data over here, we have the actual birth weights of these babies in grams, and then we have information about the smoking status of the mother. So we're going to use those two variables together to investigate this question. In general, what we're going to do is look at the birth weights of the babies, and we're just going to group those by the mother's smoker status. So we're going to look at different features of the data of the birth weights when we've got the babies divided up into two groups, whether their mother was a smoker or not. We're going to look at the similarities and differences between those two sets of birth weights. So first, we're just going to explore the data that we have. We're going to look at lots of different graphs and displays. We're going to look at the descriptive statistics and see what that might have to tell us. We're going to start with creating graphs, and we want to do ones that are appropriate for quantitative variables and appropriate for this situation. We could do a frequency distribution table. As we found out last week, when we do a frequency distribution table in StatCrunch, it creates the classes for us. We don't have any choice about that, but we'll still look at those. We'll do histograms. We can do stem and leaf plots. A dot plot is something that won't work well in this situation because we have so many different values for our birth weights. So we're not going to do a dot plot. And two extra items that are new this week are a summary statistics display. That's going to give us these descriptive statistics down here, which are very important when you're looking at a quantitative variable. And the other new thing from this week is a box plot. This is another graph that's only appropriate for quantitative variables, and it can also be very helpful in showing you the differences between two sets of data. So we'll look at those two things. When we look at our descriptive statistics, we're going to look at this whole list of values for the birth weights of the babies. So let's get started with the frequency distribution tables. So I'm using birth weight as my column, and I'm going to group this by smoker so that we get two different frequency tables. And of course it asks if I want to turn on binning for the birth weight, and I do. So here are our two frequency tables. And one thing that I would notice right away about the difference between these two is that for the smoker equals yes group, there's one baby that had a birth weight of less than 1,000 grams. In this group, there aren't any that had a birth weight that low. Another difference we might notice between these two tables is that in the non-smokers group, the highest frequency class was the 3,000 to 3,999 grams. That had 49% of the babies were that weight. In the smokers group, the highest frequency class was 2,000 to 2,999, and that had 51%. That's a major difference when we have almost 50% of these babies with much higher weights than the highest class for these babies. Now, one other thing I want to mention about looking at these two tables is that for the most part, I'm looking at the relative frequencies, because if you notice the counts between the two groups, the non-smokers had 115 total and the smokers only had 74. Since the totals are quite a bit different, then I don't really want to look at the actual frequencies. I want to look at the relative frequencies if I'm trying to compare these two. The next thing I'm going to look at is the histograms. And actually, before I do the group by, I'm going to look at the histogram for all of the babies. I'm going to change this to a relative frequency instead of a frequency. That way it'll be easier to compare with my other two graphs that I'm going to create. So now I'm going to create the histograms for the two different groups. I'm going to do this twice so that I can see them both side by side, but I want to have them set up the same way. For both of them, I'm going to do the relative frequencies, and both of them I'm going to tell StatCrunch to start the classes at weight 0. That way they'll both look similar. Now I have my two histograms. I notice looking at these two is that on the vertical axis, this one only goes up to 0.25. This one goes up to 0.3. So I'm going to squeeze this one down a little bit so that the scales are about the same. That'll make it easier to compare the two. And then I can do the same thing with this one. So now my scales match on my three graphs. Now what I see right away looking at the non-smokers versus the smokers is that the distributions have different shapes. This one has kind of a long tail on this end. It's gradually going down towards the left end. And the highest frequency class is here between 3,000 and 3,499. I'd say that most of the data for this is between 3,000 and 4,000. That matches what we saw in the frequency table over here. And for the smokers, the highest frequency class is between 2,000 and 2,499. That's much higher than the highest frequency class for this group. It looks like the smokers' babies have much lower birth weights than the non-smokers' babies. And if we compare that to the histogram for all of the babies together, in this histogram also the highest frequency class was between 3,000 and 3,499. But in this one there was much more even distribution between the 2,000 and the 4,000. It's kind of interesting that this was the babies overall, and when we split it up into the two groups, the smokers got the lower birth weight babies and the non-smokers got the higher birth weight babies. So that would be a really interesting thing to notice about what happened when we split this up into two groups. The other thing I would notice that's a major difference between these two, the values on the left and the right ends of the graph. In this one, we have at least some babies that were at a much higher weight, between 4,500 and 4,999 grams. This one, there aren't any babies in that class because it doesn't even show that class on the end of the graph. And this one, if we look at the class below that, so starting at 4,000, this one had quite a few, this one had very few. And this one also had some in this really low class below 1,000 grams. So those are just some of the types of things that you could notice looking at a graph like this. One other thing that's important in this one, if we go back and look at the description, that a low birth weight baby is considered to be one that weighs less than 2,500 grams. So thinking about that, if we look at these two graphs, the less than 2,500 grams is the highest frequency class for the smokers, is under 2,500 down to 2,000, and then after that. So the smokers actually have quite a few low birth weight babies, where for the non-smokers, the total of these three classes that are under 2,500 grams isn't nearly as much. One of the things that is new for us this week in Chapter 3 is talking about the center of the data, which is talking about the mean, median, and mode. And that's one of the things you can also do with the histogram. You can have StatCrunch put markers for where the mean and the median are. So I'm going to go back to this, and under markers I'm going to check both the mean and the median. So now I can see on the graph where the center of the data is. And for both of these, the mean and median are very close together. This one, they're so close together that you can't even see the two different markers. In this one, they are also very close together. But you can also see the difference between the two. For the non-smokers, both the mean and the median are just over 3,000. And for the non-smokers, the mean and the median are both at about 2,800. So that's a major difference between these two. where the center of the data would be. The nice thing about having it mark this on the graph is that sometimes just looking at the histogram, it's pretty hard to tell where the center of the data would tend to be. In general, when you're analyzing quantitative data, if you're doing something like writing a report, you definitely want to talk about the mean and the median. Those measures of center are really important for quantitative data. So you might want to do something like this where the mean and the median are both shown on the histogram. You also want to specifically mention those in the written part of the report. So you would want to say specifically what the mean is for both groups and specifically what the median is for both groups. Now let's look at stem and leaf plots for these. On these stem and leaf plots, the leaf unit is 100. That means that we've got the thousands digit over here as the stem. And so these are rounding things to the nearest 100 grams. So for example, in this second stem right here, this value in the data would be 1100, but that's rounded to the nearest 100. Our highest data value, the closest that we know from this, is that it's 4200. But this gives us a better idea of what those actual minimum and maximum values would be. And in both of these, it used split stems. So it's giving us the same classes as we had in the histograms. They're going with a class width of 500. So for example, this stem goes from 2000 up to 2499. And this one goes from 2500 up to 2999.